Hello friends, I welcome you all to my channel. This video is part of the playlist Python Basic Programming Beginners Daily Dose, where I come up with videos on fundamental concepts of Python so that it will help beginner level developers or programmers to get a better insight of how things works in Python behind the scenes. This video is about this is part one of the series of video that where I will discuss about shallow copy and deep copy of objects in Python. In this part one, I will briefly discuss about the shallow copy of objects in Python. Uh, it's my request that if you are not yet subscribed and if you found my videos useful and beneficial, then please support me by subscribing to my channel, like my videos, share them with your friends, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so on the right hand side on the notepad, I have briefly laid down the flowchart of how shallow copies are performed in Python. So now let's say in Python there is a module called copy where we have two functions copy dot copy where if we take an object and we have copy let's say we have an object one numeric and we can do shallow copy with the method copy. We pass on an object and we get this, and we can also do a deep copy of an object. It will return a deep copy of the object X. Now what is a shallow copy? In this video I will discuss what is a shallow copy, and in the future videos I will discuss what is a deep copy. Now in shallow copy, if the object that we are trying to create a copy of, if it's a mutable object, if it's an immutable object like numeric, strings, tuple, or range, then the copy.copy method will simply return the object that we have passed as the argument. So so let's say we have so in this case I have x equals to 12. I did copy.copy x. Let's assign this copy to a variable y. So I'm creating a shallow copy of x. The method copy creates a shallow copy. So it will create a shallow copy of x. Now if the object, in this case x, if it's a mutable object, then basically y is a reference to x, meaning y and x will point to the same data object in the memory. If I do y is x, it will return true. This is true for any kind of immutable object. Let's say I have a tuple, whatever the data elements could be. Let's say something like this. I have a tuple. Now, if let's say I create a shallow copy of this tuple. Let's say t2 equals to copy dot copy and t. So now if I do t2 is t, you see it's true. So t2 is true. The is operator checks whether two objects are having pointing to the same data object. This is done by comparing their ID. There is a function ID like this. This is same as ID t2 equals to ID t. So ID t2 gives the identifier of t2, means ID is a function that takes an object and it returns a unique identifier of the object, which is basically roughly same as a memory address of a variable in C or C++. So in this case, we see that T2 and T are having the same ID, meaning they are pointing to the same data object. Now, You can also check for range. Range is also a immutable data type. If I do some range and if I create a shallow copy and if I check, they are pointing to the same data object. R is true. So similarly, it will create a shallow copy if the object is a string or it is a, what else? Yeah, it is a string. So numeric, string, a tuple, range, these are immutable data type. So it's creating a, it's returning exactly the the reference to the object that you are, whose copy you are creating. Now, what if the object that you're passing with the copy function is immutable object? But before that, please note, when you do assignment in Python, let's say whatever assignment, when I do simple assignment like if I do y equals to x, where x is an object of some kind, it is a valid object, and if I do y equals to x, then then no copy is being created. Then y is not a copy of x. Y is merely is another reference to the data object to which x is also referring. So basically, this is y is x will always be true. So no copy is involved in assignment operation. Simply, if you assign a variable to another variable, then no object is created. The target variable y will merely point to the same data object. Now, but let's say y, we know that y x is 12. Okay, y is 12. What if, let's say, if we do, but whenever a computation is involved, a computation is involved, and expression need to be evaluated, then always a new object is created. Meaning, if I do x dot, let's say 2, then obviously a new object will be created. Now y is will be false because a new object has been created, because the new expression has been evaluated, x into 2. But if we have done x multiplied by 1, then x multiplied by 1 is same as x, then will y refer to a new object? Let's see, y is x, you see. When I did y equals to x into 1, it saw that x into 1 is basically this, the value of x into 1 is same as x. So no new data is being created. So y is referring to x. Now, so remember that when you do assignment, variable assignment, like y, something like y is equal to x, then no object is created. Merely the target variable here y will refer to the data object being pointed by x. Now let's discuss what if we pass a mutable object in the copy function. So in the flowchart, as you can see that when the object is mutable, what happens is a new object is created. Let's say we call it object 2, and then it will iterate over all the elements of the object. Since object is mutable, most probably it will be a collection object like list or sets or dictionaries or maybe some other user defined class, and that user defined class may have some instance variables or references. Those instance variables could be references to other objects. So what will happen is, be it a built-in collection data type like sets, lists or dictionaries, all the elements that are contained inside the collection object, a shallow copy of those elements will be created, and that shallow copy will be added to the new object 2 that is being created, and finally the object 2 will be returned. So basically object 2 will be a new object. It will have a different memory address, it will have a different ID than object, but it will contain all the shallow copy of all the objects that are inside the object obj object, which in most cases will be a collection object. So let's try to understand this with some code. Let's say I have, let's say, let's say I have a list equals to, let's say I have a list equals to 1, let's say 1, another empty list, let's say a tuple, 1 comma 2 comma 3. I'm taking very basic examples. Let's say another a dictionary. What else can we take? Yeah. So this is a mutable data type. This is a list. List is a mutable data type in Python. Now let's create a shallow copy of this L. Now definitely, since L is a mutable object, L2 will not be referencing to L. This will be false. So L2 is a different object, meaning it has a different ID. It has a different ID than the object, the list L. Now let's investigate how the elements of L2 are being created. Now you see the original list L, the elements where the first element was 1, which is a mutable, which is an immutable object. So no reference, no. It will be directly copied to L2. The second element is a list, which is a mutable data element. So a reference of that empty list will be created in L2. Similarly, the third element in L is a tuple. So that tuple will be simply simply copied to, as a shallow copy, copied to the L2. Similarly, the last element, dictionary, will also be shallow copied to L2. Now let's try to understand whether, let's try to investigate the IDs of the respective elements of L and L2. Let's see the first element, L0, is it the same as L20? It is true. Now L0, the list, the first element of L0, it must have some memory address, meaning it must have some ID. Now since 1 was immutable data object, L20 is merely pointing to L0. That is why we are getting L0 is L20. That is, the first element of L2 is merely pointing to the same data object which is being pointed by L, first element of L. What about the empty list? It is also true. It is also this empty list is also true. Okay. What about the tuple? Tuple is also true. And what about this? Is also true. So we can see in this case that one, two, three, four, all the elements in the shallow copy of L2, all the elements are pointing are pointing to the same data objects which are being pointed by the respective elements of L1. If according to my flowchart, which was my understanding in the flowchart, I said that if it's a mutable object, then L is a mutable object, means it's a collection object, it's a list. Then all its individual elements will be shallow copied to L2. But we saw in the code that the last element or the second element of L2 is basically pointing to the second element of the list L. According to the flowchart, L L2 1 L2 1 should not be, this should be false. This L2 1 is, according to the flowchart, this should be false, but this is coming true. Meaning, so if it's a mutable object, which obviously in most cases will be a collection object like list or sets or dictionaries, then all the elements in the shallow copy, all the elements of the collection object which is being copied uh, in the shallow copy, in the copy object, a reference of all the elements from the original object will be created. Meaning, uh, if we have, let's say this is okay, so this is okay, so let me first try. This was for list. What if I have a dictionary? Let's say let's say I have a dictionary 2 and 3. Let's say I have this dictionary and I do a shallow copy. I do a shallow copy of this dictionary. Definitely D is D2 will be obviously false because a new object will definitely be created. Also the content of D and D2 will be same, obviously. But I want to check whether the values of D and D2 are are the same data objects, or references to the same data objects, or are they different? Because according to my flowchart, in the bigger box for all elements x of object, I said that a shallow copy a shallow copy of x will be created. If this is so, then if a shallow copy of if x is a mutable object, then x2 should not be pointing to the same data object as x, because uh, initially in the flowchart we said that if object is mutable, then it creates a new object. So I think I think this is wrong. It should be rather, this was my initial understanding, this should be rather x2, not x2, the x2 will not be created at all. Simply we will add x to add x to object. Simply the x will be added to object 2. X will be added to object 2. Now I need let me see if this is the case also for dictionary. So how the keys and the values of D has been created in D2. So what if I check D2? This is the value of the key 2 in dictionary, original dictionary. Is this pointing to the same object as D2 2? Yes, this is true. And obviously this will also be true, I guess. This is true. So okay, and what about the keys? What about the keys? Since the keys are immutable data types, mm, Okay. So you can see that is so the values in the shallow copy D2, the values since the values which are strings A and B, shallow copy, references to the values are being created in D2. References of values of D are being created in D2. So now if I do, if I add an element, if I add a key value pair to D, the original list, let's say I do this, what is D2 now? Okay, so uh, if I modify D, the original dictionary, the shallow copy, D2 is not being modified. If I added a new element, key with 3 and the value empty list to D, it was not created in D2. So once you create a shallow copy, if you modify the original object, I guess it won't modify the shallow copy. Uh, unless and until you are modifying a value, you are modifying a value of a key. Yeah. So since D2 is a new object, D2 is a new object, but internally these values are references to the values of D. But when we add a new element, a new key value to D, it will not get created in D2 because D2 is now it has a new memory address. But if let's say I'm taking another example, let's say if D is an dictionary, let's say uh, this, and I create a copy of D3, this, and so D4 is this and D3 is this. Now, if I add an element, if I modify the value of key 1 in D3, so if I modify D3, the value of key in D3 by adding an element to the empty list, let's say 0. So D3 is this, what is D4? So D4 is also changed. D4 is also modified because the value of key 1 in D4 was a reference to the value of key 1 in D3. Okay. So I hope you got uh, a bit of understanding of how shallow copy works in Python. Using if you do a shallow copy using the method copy of the module from module copy, then how the shallow copy works. And uh, so the key things to remember is that when you do an assignment, an assignment operation merely creates a new reference to an existing data object, like x equals to y. If you do x equals to y, then x, if you do x equals to y, so when x, you do something like x equals to y, so this is memory, let's say this is some data, this is y. Now, so y is pointing to this, now x will also point to this same data object. And so no copy is involved. But when you do something like x equals to uh, copy dot copy x, when you do something like this, y equals to copy dot copy x, then if x is a mutable object, then this copy dot copy x will simply return x. If x is an immutable object, then copy dot copy x will simply return simply return x. So y will merely be a reference to x. So if this is mutable, this is immutable if this fx is mutable, then x will also point to y will also point to x. But if x is mutable, then a new object is created. A new object is created. If you do copy x, where x is mutable, then a new object is created. Then definitely id y not equals to id x, and y has references to all elements of the container object x. It will just have references to all elements of the container object x. Okay. So that was all for this video. In the next video, I will discuss the deep copy, which is the function copy.deepcopy, and how it works in Python with some demonstration with some examples. Thanks for watching, and until the next video, take care and bye.